Okay, and then to finish solving this one for y, you're going to divide both sides by -5. Negative 20 divided by -5 is 4. So again, it's great. You get y to equal 4, but that's not all you need to do. You need to also solve for x. So do you want to, should we plug the 4 into the top or the bottom? Bottom. So we're going to plug the 4 into the bottom equation. We do x plus 3 times 4 equals 9. So we have x, 3 times 4 is 12, equals 9. Subtract 12, and we get x equals -3. So the solution to this system is -3, 4. So there's everything with solving these systems using graphing, substitution, and elimination. Any questions? It's a lot, I know. This was a good chapter, though. You guys all did really well with this stuff. Okay, next page, last bit. This is it, story problem. Okay, here we go. This is a system, you're going to write your own system of equations for the real world situation, and you're going to be able to solve it. So it says the school cafeteria sells 2 kinds of wraps. You have a vegetarian wrap and you have a chicken wrap. The vegetarian wrap, stop talking. The vegetarian wrap costs $1 and the chicken wrap costs $1.80. Today, they made $83.20 from the 64 wraps that they sold. How many wraps sold were vegetarian? So we have to write our own system. So we do know that a vegetarian wrap costs $1. So 1 vegetarian plus the chicken wrap costs $1.80. So plus $1.80 for the chicken wrap, and they made $83.20. So for the amount of veggie wraps, $1 per veggie wrap plus $1.80 per chicken wrap is $83.20. We also know that they sold a total of 64 wraps. So we also know that veggie wraps plus chicken wraps equals 64. Because we have veggies and chicken wraps as a total will give you 64. Now we need to solve for either V or C. Do you have a variable that matches up? Yes. Which variable matches up? V's. Yep, they both match up already. So we don't have to do any multiplying to get them to match up. So am I going to add or subtract them? Subtract. So V minus V, they cancel. $1.80 minus $1 is 80 cents. C equals 83.20 minus 64 is 19.20. And then to solve for the number of chicken wraps, you divide by 80 cents. So how many chicken wraps did we sell? How many chicken wraps? 19, no, a total of 64 total wraps were sold. You have to divide this. What is it? 24. So we sold 24 chicken wraps. The problem, though, wants you to figure out how many vegetarian wraps. So 24 minus 64 is how much? So 64 minus 24 is how much? Huh? 40. So we sold a total of 40 veggie wraps. Huh? Okay, any questions on how to set it up? All right, last chunk that we did in chapter 4 were these linear inequalities. This stuff's kind of hard. Okay. These are what your linear inequalities look like. We had things with solid lines, dashed lines, and shading going on. So what's going to happen on your exam is that it's still going to be multiple choice. You're going to have to figure out which one it is, and my goal today is to try to help you with that. So you're going to need to be able to look at these graphs and figure out how to eliminate possible answers. So like for A here, first thing I see is that this has a solid line, which means that all of them should be equal to, and these ones all are equal to already. The next thing that you could do for yourself is to figure out what the actual equation of the line should be. So I do notice that my line from left to right is going down, which means it has a negative slope, which means they all have a negative slope. The other thing I notice is that my line has a y-intercept of 3. Do you see that?
Yeah.
So if it has a y-intercept of 3, we can eliminate this one and this one because those ones have y-intercepts of negative 3. So then what you do, we've eliminated those two. You can either flip a coin, or do you see how all of it's shaded below the y-intercept? It's below. Below means less than. This is your less than sign, so that's your correct answer. You remember this? Mm-hmm. Yeah. Yeah. Okay, so for B, first thing I notice is that my line is dashed. Dashed means that there's no equal to. So that means that I can eliminate this one and this one. The next thing I notice is that my line from left to right is going up. So that means it is a positive slope, which they both have that. And they both also have a negative y-intercept. Now, here is my y-intercept. I have to figure out where is this shaded, above or below. And it's above, which means it's going to be greater than. So that's why the answer is right here. The y-intercept. And then for C, we have a dashed line. So that means that it should not have an equal to. So we can eliminate this one and this one. Both of these are at -1. We have to determine this x and y tell us which axis it's crossing through. So is our line crossing through the x-axis or the y-axis? The x. So that's how you can use your process of elimination there. Okay? Any questions? Okay, this last chunk is my favorite in the whole entire world to teach when we have a normal school year because this is when we colored. I think we used colored pencils for these. I don't know if you remember that. So we had to graph these. When you are graphing a system of inequalities, you graph each of them separately. And I'm going to use blue for this top one here to show you how to graph them. So we have, you treat this exactly like you would if it were a normal line. You plot your y-intercept, which is 4. And then you use your slope to find the second point. So my slope in this case is 1. So that means you go up 1, right 1, up 1, right 1. Then you look back at your equation or your inequality and there's an equal to sign. So that means when you connect your dots, you use a solid line. These ones take a bit, so I think I'm just going to do this one instead of doing both. Once you drew your line, then, I don't know if you remember this part, but we have to figure out where to shade. We picked a test point. Do you remember that? Yes, there we go. So do you remember what we always use for our test point? 0, 0. Good job. Because our line is not going through 0, 0, we're going to pick 0, 0 to see, are we going to shade on the side of my line where 0, 0 is, or are we going to shade on the other side? So you plug 0, 0 in for x and y. So we get 0 is greater than or equal to 0 plus 4. So we get 0 is greater than or equal to 4. Is that true? No, that's false. So that means that you don't shade on the side of your line where 0, 0 is. You shade on the other side. Then, I'm going to use green. We have 2x plus y is less than -2. So to graph this one, if this were back in February, you guys would just want to find the intercepts, but we're not going to do that this time. You want to get this in slope-intercept form. So how would I get this in y equal, or y, get y by itself? Subtract the 2x. So then you would have y is less than negative 2x minus 2. This is what we are going to graph. So we plot the y-intercept at negative 2. Put a dot. Our slope is negative 2, which is the same thing as negative 2 over 1. So that means from your y-intercept, you go down to right 1, down to right 1. Do I connect my dots with a solid or a dashed line? Dashed, because there's no equal to. So you do a dashed line. Then you have to pick a test point, because we have to figure out where am I shading. So what do you want to pick for your test point? 0, 0. So we have 0 is less than negative 2 times 0 minus 2. So we have 0 less than, let's see, that's 0, negative 2. Is 0 less than negative 2? No. So that means looking at your line here, we do not shade where 0, 0 is. We actually shade on the other side, and the actual solution of your system is where your shading overlaps, which that means this is the actual solution. And that's how you have to do all of these. Yeah. Yes. Now, these will be multiple choice. So the hard part on these is you're going to have to look at the graph and figure out which ones go with which. So now that maybe you've seen how one is done, you can maybe work backwards from that. So today on your review, you need to take a look at 1 through 10.